Welcome back. We are going to learn a set of new operators in this topic. I'll start with bitwise operators. What do you think the bitwise operators can do for us? They can perform logical operations bit by bit by converting the values to 8-bit values. Let's say, for example, we assume A is equal to 54. Its 8-bit value is 00110110. Of course, you need not memorize this. The system will be able to do this for you. Let's take one more. Assume B is equal to 66. Its 8-bit value is 01000010. All the possible bitwise operations are covered with the help of A and B. So what kind of operations you can do? When we talk about bitwise operators, we have bitwise AND, bitwise OR, bitwise XOR, bitwise ones complement, binary left shift, binary right shift. These are all the different operators that exist when we talk about bitwise operations between two variables A and B. I'll explain it to you one by one. Binary AND, which is usually represented with the help of ampersand. It performs a bit by bit AND operation. That is, if you're asking for A ampersand B, that is, we consider the value of A as 54 and B as 66. Now it's going to look at the 8-bit value of 54 and 66 and then compute this operation of ampersand, this operation of AND. So the outcome of it will be 00, 00, 00, 00 and 10. Now compare the 8-bit values of 54 and 66, you will be able to understand this. Same way, you can also perform OR operation or exclusively OR, that is XOR operation. When we say XOR, it talks about copying the bit if it is set as 1 in one operand. So that's how the XOR operation works. It is usually represented with the help of the exponential symbol. Binary ones complement can be applied to one operand and each with comp. That is, when you say tilde, the tilde, what we call it as, that is the usual representation of this binary ones complement. Tilde A means 11001001. It is just doing the opposite. You can do left shift, you can do right shift. So overall, if you notice, the binary operations can be easily performed with these bitwise operators. You are converting everything into zeros and ones, 8-bit value, and then you can play around with these 8-bit values with the help of all these operators. I hope you got some clarity about bitwise operators. Now let's look at identity and membership operators. So what do you mean by identity operators? The Python identity operators are used to compare the objects to see if they are actually the same objects or variables with the same memory location. If you remember, we can assign value to a variable, we can assign reference to a variable. So when you are assigning reference to a variable, it is the same memory location that you are trying to tap. So you are using identity operators to check whether two variables have the same reference or using the same object. That's what we are trying to find here. So there are two identity operators here. One is, the other one is not. So when we say X is Y, it returns true if both variables are of the same object. If I say X is not Y, it is going to return true if both the variables are not the same object. So in a way, this is helping me to assess and understand how the identities of the objects are, how they are stored. Now moving on, we have Python membership operators. These operators primarily test for the membership of operand on the left in a sequence on the right. The sequence can be a list, it can be string, or it can be tuples. So these are some data structures which you are going to learn down the lane in this program. But for now, let's assume that they are different data structures. So some of the operators here are in, not in. When we say in, it evaluates to true if the operand belongs to the same sequence. Not in will return true if the operand does not belong to the same sequence. So this membership operation is primarily to check whether they are in the sequence or not. So in this particular topic, we have understood three different operators: the bitwise operators, the identity operators, and finally the Python membership operators. Now it is time for us to try this hands-on using our notebook. So can you please open your notebook? We will try things together. Thank you.